Okay, so today as we talk about functions further, there's a few more definitions that we're going to have to know. So something that we've already done, we've just never referred to it as a discrete function. A discrete function is when you need positive whole numbers. Remember, whole numbers are like 1, 2, 3, 4. Positive whole numbers, these are also referred to as integers for the input, meaning for the x. So for example, if your input is bags of candy, you can only have whole number bags of candy. Another example of a discrete function would be number of books. So a discrete function is just where your input is positive whole numbers. Now when you have a continuous function, that means that there's no gaps. There's no gap values for the input, meaning for the x value, which means you have fractional. You can have a fractional value, which really is a decimal. So the biggest example of this you'll see is time. You're going to have a fraction value for time, right? You can have 1.5 seconds, 1.25 minutes. So the difference between those is that a discrete function, you need to have a whole number. In a continuous function, your x value, you can have a fraction. So nonlinear functions. Remember, if it's a linear function, it has a constant rate. And remember, if it's linear, the exponent has a value of 0 or 1. And that should say value here. So if it's a nonlinear function, essentially we're doing the opposite. The rate is not constant. So it's still a function, but the rate isn't constant. And the exponent does not have a value of 0 or 1. So if you remember back from when we started our fourth unit, that was one thing that we had to know about linear equations, was that they had to have an exponent of 0 or 1. So something that we're going to talk about later on, we're going to be given examples in the end of our lesson today where we're going to be given a function that cannot be described by numbers or symbols. But just because it can't be described by an equation or rule, it doesn't mean that it's not a function. It could still be a function. You're going to see an example like that today while we go through our classwork. Okay, so I'm going to walk you through just how to put a function as an equation and to go through, define your variables, write your limitations. So I'm just going to walk you through another example. This way today when you finish, when you need to do your lesson 4 exercises, you have something to refer back to. So we have Mrs. Bador runs 13 miles in 2 hours. Write the rule that describes this function. So the two units I have are miles and hours. And I'm running 13 miles in 2 hours. Remember, you always set it equal to y over x. I'm going to cross multiply. I'm left with 13x equals 2y. You always solve for y. Divide each side by 2. And I get y equals 13 over 2x. I can also write this as y equals 6.5x, since my fraction works out to give us a nice decimal. So there's my equation. Y equals 6.5x. A few other things I'm going to do. I'm going to define the variables. So I have x. If I look back at my proportion, this helps me. X equals hours, and y equals miles. I'm now going to describe the function in words. So the miles Mrs. Bedore runs. Now remember, the miles Mrs. Bedore runs, that's all y. Remember, this is where you got to put is a function of. This is the same no matter what function you have. Is a function of the hours she spends running. Some limitations that we could say. When wouldn't this function make sense? So since my x is hours, x cannot be negative. You can't have a negative time. So since x cannot be negative, it has to be positive. It has to be positive. Now the question I asked, can x be 0? If x is time, can it be 0? Yes. So I'm going to write my limitation, x has to be greater than, or it can be equal to 0. Last thing I'm going to do, I'm going to assign to this limitation. I'm going to assign. I want us to figure out how many, let's see, so we have our function as y equals 6.5x. So I want to figure out, I want to assign 3 hours. And I want you to tell me how far I would run. So 3 hours, hours was my x. So I have my equation y equals 6.5x. And now I'm going to plug in 3 for x. So I have y equals 6.5 times 3. If I plug it into my calculator here, let's see, 6.5 times 3. So y would equal 19.5 miles. So what that means is that in 3 hours, I would run 19.5 miles. Okay, I hope that helps. Make sure that you follow the checklist for lesson 4 examples. That's what you have to do next. Lesson 4 examples. Make sure you follow your checklist and have those done ready for class today.